So here are the answers to the questions at the end of the previous chapter. Hopefully you've got all these right. So why don't you tick these off before we go on to recycling. Now recycling means to make new items out of old waste metal items. And it's different from reusing. It doesn't mean the same. Reusing just means to use an item again without changing it into something else. Now recycling metals is good because it reduces the overall energy consumption. Recycling metals is important because if you're extracting them from the ground and going through all those steps, that uses up precious resources and energy, and that has a harmful impact upon the environment. So recycling saves energy. What are the benefits of recycling metals? Well, environmental benefits are that there's less use of energy or fossil fuels, there's less mining and quarrying, so therefore there's less destruction of habitats, and there's less CO2 produced. Social benefits: recycling plants are quite big industry now, they can create a lot of local jobs. And ethical benefits are that it saves precious resources. Properties and uses of metals. Properties of metals. Metals are malleable. That means they can be bent and hammered into shape. They're ductile, which means they can be drawn out into wires. They're strong. They're good conductors of heat and electricity, and they have high melting and boiling points. Now the thing about pure metals is that many metals are very soft in their pure forms. For example, iron, copper and gold, when they're pure, they're too soft for many uses. Pure metals are also very expensive. So they're often alloyed with other substances. This means they're mixed. Now, this diagram shows pure metal. All the particles are of the same type. The downside of pure metals is that they can be too soft and too expensive for a lot of uses. So we alloy them to change their properties, to make them harder, for example, or cheaper. It's not to make them a nicer colour or to make them shinier or to make them brighter. Don't say that in the exam. Now, alloys contain a small percentage of one or more additional substances. So it may be a small amount of another metal that's introduced, or it may be carbon. So this diagram shows an alloy. You can see that it's a mixture. So if you remember a mixture, it's two or more types of particle that are not chemically joined to each other, and you could actually separate them. Now, alloys tend to be cheaper than pure metals and they tend to be harder. We can alter the properties of metals by alloying them with different amounts of different substances, depending on what properties we want of that metal. Alloys can also be more resistant to corrosion than the pure metal from which they are made. Steels. Now iron, straight out of the blast furnace, contains about 4% impurities, which is high, and this makes it too brittle for use as anything other than cast iron, for example gates. So most iron is then converted into different steels. Now steels are alloys of iron and carbon, and sometimes other metals too. Low carbon steel is easily shaped. High carbon steel is very hard. Stainless steel resists corrosion, so that stays shiny over time. The transition metals are the central block of the periodic table, and we describe them as typical metals. They have all the usual properties, malleable, ductile and so on. They're useful as structural materials, but they're also useful if we need heat conductors or electricity conductors. Aluminium and titanium are very important metals. They both have low density, which means that they're lightweight metals, and they're both very resistant to corrosion. Copper is a good conductor of both electricity and heat. It can be bent into pipes for use in plumbing. It can also be drawn into wires for use as electrical cables. But it's still hard enough to make water tanks. Crucially, it's unreactive, so it doesn't react with water, so we can use it in plumbing. Okay, so quickly test yourself. Hopefully you've printed out all these notes so you can answer it now and find the answers at the beginning of the next chapter.